Mr. Jamal Abdul Nasser Shukuri. He is from Institute of Earth Surface Dynamics, University of Lausanne, Switzerland. So the topic of his presentation is sustainable household water saving and demand management options for Kabul City. I would like to ask him to unmute his microphone and start his presentation if he is ready. Mr. Jamal Abdul Nasser Shukuri, are you ready to present your presentation? Can you hear our voice?
Can you hear me now? It's okay, the voice?
Yes, I can hear you.
Okay, I will share my screen. Okay, so now it's okay. The screen is okay.
Yes, we can see. So you have 15 minutes to present your slides, and after that, we will have 5 minutes question time. So you can start now. Your time is.
Okay, thank you very much. So I will go very quickly to for the 15 minutes. Thank you very much for the organizing this chance. Saving and demand management options for Kabul City. Okay, so what is the current status? If you look at the map, it's a Kabul City, and then the main important thing that I would like to point is like the total 39% of the whole area is a build-up area, and then we have only 61% of the area which is non-build-up. It means this white color, and also it's covered with the mountains. So just keep in mind this figure. We will come back to this. The Kabul city is the fifth fastest growing city in the world, and according to CSO, the population is estimated about 3.9 million people in 22 districts. If you come regarding the water resource, major resources, so the major resource of water is groundwater currently. So there is no alternative source that people are using. So everyone is using from the groundwater, and the map shows the groundwater decline from 2007 to 2017. It means 10 years of groundwater decline. So if you look at this area, it's almost 30-meter groundwater decline has been occurred in this 10 year. And here it's about least decline because it's an agriculture area, but the more decline is in 30 meters, very dense population area. So how much water is extracting currently? If you look at the map of the city again, so the points are the 96 production wheel abstraction, which is 21.5 million cubic meter per year. And then if you look at only an example of one district, which is District 13, you could see that there is 70 private water supply companies providing the supply for the people. The abstraction rate is cubic meter per year. And then if you look at another part, which is District near to the District 7, this area, which is agriculture, irrigated wheel, with about 106 irrigated agriculture irrigation wheels. So 11 million cubic meter per year is the extraction. So you can see the huge amount of extraction is currently occur around the city. And just like the land subsidence, and a study with the company which is called Land and Mills, which is working with the Ministry of Energy and Water, and they have within 1 year from 2007 to 2008. Only within one year, so large subsidence has been offered about 3 millimeter of the dense, like the populated area has settled down. So this is a very huge problem currently, that the people are over extracting the groundwater, and then land subsidence is starting. If you look at the conceptual model that how much water is available currently in the city in terms of groundwater, so the annual precipitation is 344 millimeter, and then according to the FAO 1996, that if we assume this precipitation only 10% as a recharge rate, so this 10% will be 21.65 million cubic meter. It means that every year we will have 21 million cubic meter from precipitation, which is recharging the groundwater, and 4 million cubic meter is from the river, which is crossing the inside the city. So the total potential is 25.65 million cubic meter. In another hand, if you see the usage, it means if you see the 4 million population is using 60 liter per day per capita, so it's 87 million cubic meter. So we are almost minus 62 million cubic meter of balance. So it means that we are using our groundwater, those ancient resources. So only 25 is renewing every year. So if this is a glass of water, we assume this glass of water is Kabul City, but every year you can see the number of the wheels it's increasing. So the people are assuming, okay, if you dig a new wheel, so we'll have a new water, but it's not the case. The water is just it is, but the number of the wheels are increasing day by day. There are plans from the government. If you could see that this is the red color is the city area, and there is several dams around which the government has planned to build, but still it's almost 10 years, I can say, that they are on the paper. So our suggestion and our solution to this is the long-term plans are good, but we need to have the short-term plans ahead with. So the short-term solution, the paper is focuses two options. One is the tapping new water resources, the rooftop rainwater harvesting, and the second one is demand management, how to manage the demand. Let's go to the first one. Rooftop rainwater harvesting is a kind of usual technique that many countries are using. It is just kind of how we could collect the rainwater from the rooftop of several structures like apartments, institutions, and houses. So how much do we have? I mean, how much rain do we have that we want to collect around Kabul City? So this is the data from 1960 to 1984, and then the new record. There is a good potential of rain, which is from the January to the May, and also November to December. But it's a very good amount of rain that could be harvested from the rooftops. So why we want to do rooftop rainwater harvesting? If you look back to this map, you could see that many developed build-up areas, 29%. So many people, they use the materials which uninfiltrable. It means it doesn't want the water to go to infiltrate, to recharge the groundwater. So that's why many area has been with the concrete, with the so that's why our recommendation is to do rooftop rainwater harvesting, because no more spaces for the groundwater recharge around the city. So where to implement this rainwater harvesting? Our study area is focused on the several infrastructure that will come in the next slides. Yep. Okay, so how much is the potential? So how much water we could store from those structures? You can see that 38 million cubic meter we have the potential. 38 million cubic meter where? From the regular houses, irregular houses, houses which is in the hillside, in apartments, and in several and commercial area, and institutional area, industrial area, and roads and streets. So this is a very huge potential that we could collect those rainwater from these structures. So if you could see that only house regular and house irregular and houses in hillside has a very huge amount of potential that we could collect those kind of rain only in these three structures. And if you assume that an area of house with 150 square meter of the rooftop for the 6%, it could survive in January, February, March, even you can see 50 liters per day per capita. And if we supply this water for in return, like low-class people, it's very well survived. So if there is no any other source, only rain could survive these people, and January until April and until May. So what technique we want to propose is, like the first thing, okay, in case of recharging the groundwater, this structure is very simple structure that could be dig along the roads and that could collect the road water and guide it on the groundwater. So it's not so expensive. It's about $80 per, like 2 meter depth and 1 meter diameter. And another structure is just if we don't want to do recharge, but if we want to use it as it is, for dishwashing, for the greenery. So it's a kind of 3,000 liter storage tank we could have, and it's kind of $100, and we could give back the revenue is like per year $36. We can receive the revenue back because we are paying for water. So it's a free one. How do we manage the demand? So that was the case of some alternative resource. So there is a good potential that we could store, and there is a good technique that we could store in, and it's a very huge potential. And let's see inside of demand management. Many people especially in developed countries, they're using some faucet aerators. In like countries in Afghanistan, we don't have such kind of filters in the faucets, and many times we just remove it because we want more water to come out, while only this faucet could save 30 to 50% of the water. And then low flow shower heads. This shower head could save the water 30 to 50%. It's just mixing the air with the water. And also there is a pattern, because many people is social behavior, like once we set the water with a certain amount of cold and warm, then we are not going to shut it off. But this pattern could help us to several times shut it off during the taking bath. The second demand management option is the double flush toilet. So the historical or the previous tank of the flush toilets, they use about 7 to 8 gallons per flush. But this double flush toilet is decreased this amount 80%, 70 to 80%, like 0.8 gallon per flush if you could install it in a state. And then gray water reuse, the water which come up from the bath and then from the kitchen, only the gray water could be reused again back for the greenery and for the car washing. So it saved 80% another water here. So what? So we have those options. So what will happen? So let's see if we apply those options in one of the area in Afghanistan. Like here, we call it Macrorayon apartments. So these Macrorayon apartments, you can see that the first, the second, third, and the fourth Macrorayons with a 100 people population. So this is a kind of 16,000 cubic meter per day supply from water supply company. And then for each person, there are 125 liter per day per capita is supplying. So how we could reduce it? So current supply is 125 liter per day per capita. If we apply the low flow fixture, so we reduce the amount of uses. Like for the toilet, currently we're using 37 liter per day, but it can come to 18. And then the rest, like we reduce the consumption from 125 to 75 liter per day per capita. And if we apply the recycling, it means that to recycle some of those water, and then we could reuse it for the toilet, and then we do some more saving, and the consumption will come from 125 to 57 liter per day per capita. So what will happen? So currently like 4.9 million cubic meter per year is supplying to these apartments. Once we apply these kind of water saving options, so we are saving like about 2.4 million cubic meter. Half 50% we do saving, and we could supply this saving to another population of 100 people. So this is a good saving to be happening. Yep, that was all. So we could say that sustainability should not be only in our speech, it should be in our actions. So it's an obligation of each and every resident that could save water and save life. Thank you very much.
Thank you so much, Mr. Shukuri, from your nice presentation. And so we have more than 5 minutes, I think, available for a question session. So I would like to see if any of participants have a question. They can raise hand and ask their question directly from Mr. Shukuri to answer. So
I can see here is Ubaidullah. Sophie has a question, I think.
Yes, he can directly ask question. Mr. Sophie, please.
Thank you, Mr. Shukuri, for the nice presentation. I'm Ubaidullah Safi from Nagoya Institute of Technology, Japan. It was a great presentation and nice suggestions for the demand management. As I saw that there was some engineering techniques for the demand management, like using some types of showers and other accessories to reduce the amount of using water. I would like to also ask, is there any also soft techniques like awareness of people that could affect the uses of water and safe water? And also additionally, I would like to ask about the method of this study. Was it only from on-site data collection, or there is also any software or simulation method available for the suggested for the suggestions? So could you please give some more information about these 2 points? It will be highly appreciated.
Okay, thank you very much. So there's the 2 questions. One question is about the what else we could do. I mean, your question was how the awareness program could have effect or not. And the second question was what method I use for this research. So come to your first question about the awareness program. I do agree with you is that awareness has a toppest or has the highest effect for the people that we could say, okay, that they could do some kind of saving. My question here is like, so when we do awareness program to the people, we should propose them, we should suggest them some solutions first, and then we could say, okay, you need to do like that, and then to see the impact. Like for this presentation, if we suggest such kind of solution to the people first, we should show them, okay, these are the solutions are available, and then we could go for the saving. They are the people that they do saving not us. So yeah, you are right. The awareness program has its own effect, but we need to propose them such kind of solution first, and then to see the impact if the people are applying those suggestions or not. And the second question, the method, I use a general method. It's a kind of disk research method, not a very high simulation like these things. So what is the technology available? Because the technology has its own how to say, standards. So we use those standards, and then we compare it with the standards that we are currently using Afghanistan like. So this is a kind of simple secondary data analysis.
Thank you for the giving more information about the research as well. It was so interesting. Thanks a lot.
Yep, you're welcome.
Thank you. Thank you from Mr. Safi for his question, and also thank you from Mr. Shukuri for his reply. I would like to see if we have more questions. So I would like to ask a question from Mr. Shukuri. Again, thank you for the nice presentation. It was interesting for me. I would like to know, have like possible to have a clarification on, is there any incentives to be proposed for the government, to be proposed by the government for the people? Because economically, for example, using like new accessories, maybe it's like cost effective for the people, especially for the those that they are not able to update or modify their system or go through a renovation. So is there any incentives also proposed to be proposed to be suggest for the government that can propose as an incentives for the customers. I would like to know this point, and which is also a kind of, it's kind of demand side management, I think. Yeah, I think I want to hear first.
Thank you very much. Really a nice point. Like, let's see what other countries are doing. Like, if you see the USA, their own agent, they have a specific agency. So what they are doing, they're giving subsidies for those accessories. Like if a household wanted to renew their faucet aerators, so they are going to asking and giving their proposal to the government agency. So they are the government then providing subsidies for those kind of technology for those people. So yeah, for sure, the incentive from the government should be subsidy for these kind of technology, that the people, to encourage the people to replace their old technology with the new one. So the only way it could be subsidies from the government side. And the second one, the other countries did it. They banned the import of the old technologies which how to say, which use more water. So there are two options. One option is to ban the import of the technologies which use more water, and the second one is to give subsidy for the people, to encourage the people that they could replace these new technology with their old one.
Thank you. And one more question, not question, it's kind of a suggestion. What do you think about government, for example, if you start some case studies from governmental sites rather than private houses, yeah, or commercial. For example, if you start from governmental sites like military or school or some ministries, for example, in the country, in cities, which I think it shows it's kind of a motivation for the people, because once people are in touch with those places, that they can see and they might be interesting. And it's kind of, as there was a question from Mr. Sophie, it's kind of like indirectly kind of awareness for the people, because if you, maybe we have many people in developing countries, especially Afghanistan, that they are not familiar with such accessories, how to use them. So what do you think? Because I'm thinking that government, if you start from government facilities, it might be more easier for the government and economically as well, that they can implement. Maybe it might be interesting that you can include in your future research, I think.
Yep, you're 100% right. Like, if the government, if they start the first implementation on their institution, then the people could replicate or copy those things. So I have seen some kind of activities inside the government, which is a good point. Like, now they are collecting the rainwater from the institution to directly bring it to the groundwater to recharge it. So yes, I agree with you. If the government starts such kind of activity first on their own institution, like I showed in the presentation that only 7 million cubic meter could be harvested only from the institution area which belong to government. So if we compare the 7 million cubic meter with there is a dam called Showerheads Dam, which is 9 million cubic meter capacity. So if you compare the 9 million cubic meter capacity of Showerheads Dam with 7 million cubic meter capacity that they could collect from the rain, and then it's a very huge difference in the costing also. So this dam is $50 million is costed the government, the Showerheads Dam. But this 7 million cubic meter of water which they could collect from the rain and then guide it to the groundwater is less than $1 million. So it's a huge difference. I agree with you that if the government starts such kind of implementation, it would be great.
Thank you.
We put it in our recommendation. We will put it in our recommendation.
Thank you so much again for the presentation and answering the questions.